Hello everyone, in this video we are going to discuss the parametric differentiation. Given that the function x is equals to t squared and y is equals to t cubed minus 3t. Evaluate the dy dx at the point 3, 0. So now we are going to differentiate x respect to t. So in here we have dx dt equals to 2t. For the y will be dy dt equals to 3t squared minus 3. Next we are going to find the dy dx. So dy dx will be equals to dy dt multiply with dt dx. So we will have 3t squared minus 3. Please take note we have dt dx. So in here is dx dt. So what we have to do is to flip the situation. So we have to multiply with 1 over 2t. So finally, we will have 3t squared minus 3 over 2t. So where we have dy dx. Then the question asks us to evaluate the value of dy dx at the point 3, 0. 3 is the value for x and 0 will be value for y. So now we are going to substitute the 3 into the equation and 0 also into the equation to identify the value of t. So we have 3 is equals to t squared. So t squared minus 3 is equals to 0. So where we will have t minus square root of 3 multiply with t plus square root of 3 equals to 0. So t will be equals to square root of 3. T will be equals to negative square root of 3. So if we substitute the 0 into the equation, we have 0 equals to 3 cubed minus 3t. After we factor the situation, we will have t bracket t squared minus 3 equals to 0. So where t equals to 0, t squared minus 3 equals to 0. So if we simplify or factorize the situation, and we will have t minus square root of 3 bracket t plus square root of 3 equals to 0. So finally, t will be equals to 0, t will be equals to square root of 3, and t will be equals to negative square root of 3. So notice that we have two same value, meaning that the t will be equals to square root of 3 and the t also equals to negative square root of 3, where t equals to 0 is not valid. So now we are going to find the dy dx when t equals to square root of 3. So by substituting the value, we will have 3 bracket 3 minus 3 over 2 square root of 3. So finally we will have 6 over 2 square root of 3. And if we simplify, we will have 3 over square root of 3. Then we have to multiply with the conjugate so that we can rationalizing the denominator. The denominator will be square root of 3. Then we will have 3 square root of 3 over 3. So finally, the answer or the value for dy dx is equals to square root of 3 when the t is equals to square root of 3. So now we are going to find the dy dx when t is equals to negative square root of 3. So if the t equals to negative square root of 3, the dy dx will be equals to 3 bracket 3 minus 3 over negative 2 square root of 3. So we will have 6 over negative 2 square root of 3 equals to negative 3 over square root of 3. Again, we have to rationalizing the denominator multiply with the conjugate, where the conjugate is square root of 3. So we will have negative 3 square root of 3 over 3. Finally, the dy dx will be equals to negative square root of 3 if the t is equals to negative square root of 3. Now we are going to discuss B. Find the point xy where dy dx is not defined. In order for the dy dx is not defined, meaning that the t cannot be equals to 0. So here they stated that for what value the dy dx is not defined. So the answer is t is equals to 0. If the t is equals to 0, the value of x, if t equals to 0, the value of x will be equals to 0. If the t equals to 0, then the value for y also equals to 0. So what is the point where the dy dx is not defined? So the answer is the point will be the origin where the dy dx is not defined. So now we are going to discuss the C. So first we are going to find the second derivative. So before we start, we have to know what is the formula for the second derivative for the parametric equation. So second derivative is equals to differentiate the dy dx with respect to t. Then do remember to multiply with dt dx. So first we are going to differentiate the dy dx, where 3t squared minus 3 is a u and 2t as a v. So we are going to use the quotient rule to differentiate the dy dx. So begins with v, where we have 2t, multiply with u prime, where we will have 6t, minus u multiply with v prime, where we have 2 over v squared. So we will have 4t squared. Do remember to multiply with dt dx. So do remember we have dx dt. So meaning that we have to flip the situation, become 1 over 2t. Next, expand the numerator and simplify it. So we will have 12t squared minus 6t squared plus 6 over 8t cubed. So simplify the situation and we will have 6t squared plus 6 over 8t cubed. So for the second derivative, we will have 6 bracket t squared plus 1 over 8t cubed. So if we simplify, we will have 3 bracket t squared plus 1 over 4t cubed as a second derivative. So now refer to the question. The question asks us to determine the interval of t such that second derivative less than 0. So kindly refer to the situation and we have 3 bracket t squared plus 1 over 4t cubed less than 0. So we will have t squared plus 1 over t cubed, which is less than 0. So as we all know, this is a simplest form and this is an inequalities. So the sign would be a negative sign. So t squared plus 1 is always positive. And for t cubed, we can split it into 3 factor, which will be t greater than 0 for 3 times. We have to assume positive. So by having a number line, putting a value 0, illustrate the situation in a number line. So we notice that we have 3 times negative, so we will have negative on the left and positive on the Right. So based on the sign, we want the negative. So this will be the answer. So our answer or the interval will be negative infinity until 0, where 0 is not included. So here we are, and thanks for watching.